Hello guys, so in today's video we're gonna dive deep into our lecture 3 in AP Calculus BC. So we're starting with our actual calculus concepts, so these are really addictive. You know, just in case. So first of all, let's talk about the goals of calculus. Goals of calculus. Okay, it basically has two goals. The first goal, find tangent to a curve at a given point. Now, okay, let's see, just at a point, okay? So fine, first of all, let's talk about what is actually tangent. I guess the whole board is visible. Yes, it is. So, first of all, let's take a circle, okay? This one, this line is the tangent. This line is called the tangent because, okay, it's not quite drawn up to scale, but this line passes through the circle, it touches the circle at one point. Oops, just a minute. Okay, this is just fine. It touches the circle. Okay, this is just a circle, not O, okay, at one point. So this is an example. I'll give an example of tangent in a curve, okay? Okay, let's see this graph. We have this curve, okay? This line is a tangent because it touches the curve at only one point, this point. And they're asking us to find the tangent at this particular point. Then you can say that we can use calculus. So that's the first goal. So the second goal, find the area under a curve between 2 points. Under a curve, let's say this is a curve. This is not S. This is okay. This is a curve. This is a curve. Okay. This is the short form, so that you can save time while we are taking notes and also some pages. Every little counts, right? So between 2 points. Between 2 points. So, let's say they give you a curve. Let's not be too precise. Okay, this curve. They're giving you this point, the coordinates of this point and the coordinates of this point. And this is the area, okay? They're asking you this area, then you can use calculus. So these are the two goals of tangent. Now we have to talk about the secant. We spoke about the tangent already. Now about the secant, okay? So let's say it's fine. So let's take the circle again. This is a secant because this touches the circle or cuts the circle at these at 2 points. See, the edge of the circle, like the circumference, is being touched in 2 points. So that's called a secant. Okay? Even if you take a curve, okay, let's say this curve. Now this is a secant. Okay, it touches at 2 points. So Now we're diving into something called limits using this concept. Let's say this is point A and point B, okay? What if the points were something like this, A, B? You can't even find the difference between them, okay? I mean, the distance between them, because A tends to be, A is almost B, okay? So there's not much distance. What they're saying is, for example, if A is 0.000000009, okay, I would say B is 0.000000000. Wait, what? Oh, I see. So they give you something like this. I guess it's pretty cool. 3, 6, 7, 9, 1, right? So now the difference. No, not even 9. 0.0000001. Okay, just a minute, guys. Sorry about that. So there's not much difference between A and B. So that's really, really close, right? So if A tends to be secant tends to tangent. Okay? So the secant tends to tangent. That is, this is almost only 1 point. See, this is the secant and the tangent because it's almost only 1 point. So let's write the basic definition of limit, not a full-fledged definition, just for our understanding, okay? So a limit is basically, a limit just means really infinite times, okay? So really infinite times close. So that's very close. What example I gave you is what a human could calculate. It can be like 0.000 like that. That's 9 into 10 power minus 2000. That could even be the difference. So that must be really close. Okay. Okay, let's take a look at 2 examples for that. Limit x tends to 5, x minus 4. Addressing this, okay? X tends to 5, okay? If x tends to 5, the limit tends to 5 minus 4, right? So approximately 5 minus 4 equals 1, okay? So the limit equals 1. We don't say the limit tends to because it's already really close. So the limit is equal to 1. You can represent limit as LIM or also LT. Cool? Pretty cool. So if they give you something like this, you'll easily do it. But let's say we're in a complex one. Not actually complex. If you know basic algebraic identities, you will pretty much do it. So say x tends to 1, okay? X squared minus 1 by x minus 1. See, now this is, if you directly plug in x, 1 minus 1 by 1 minus 1 is 0 by 0. Okay, so what the heck is this, right? So, we can directly use identities. So this is equal to limit x tends to 1 again. So x plus 1 into x minus 1. It's not pretty complex. By x minus 1, okay? So cancel equals x plus 1 equals, if you plug in here, this is 2. So this is basic. Let me give you an actual complex, really complex example. Okay, now you might, find it pretty difficult and you might pluck the brain out of your head. So just a minute. Sorry, extremely sorry. Okay, let's take this question. So They're asking the limit. Okay, first of all, n tends to infinity. Okay, infinity limit. 1 minus 2 plus 3 minus 4 plus so on minus 2n divided by the square root of n plus n squared plus 1 plus the square root of 4n squared minus 1. Okay, fine. This is a really complex question for most of the people. So let's just begin to solve the answer. Okay, fine. So 1 minus 2 is equal to minus 1, right? 3 minus 4 is equal to minus 1. 5 minus 6 is again equal to minus 1. Like that, if you take 2 numbers, you get minus 1. If you take 4 numbers, that's minus 1, which is minus 2. So if you take 6 numbers, it's minus 3, like that. So if you take 2 numbers, that's minus 2n divided by 2, which is minus n. Make sense? So the numerator, the whole numerator is minus n, okay? Divided by, here you can take a clever way, you just have to cancel this n so that you won't get infinity as the answer. So let's take n squared common in this group, n squared into 1 plus 1 by n squared, okay, plus the square root of n squared into 4 minus 1 by n squared, okay. Now we can take this n squared out. Limit n tends to infinity minus minus n by. So we can take this n out. N into the square root of 1 plus 1 by n squared plus the square root of 1 square root of 4 minus 1 by n squared. Okay, so this cancels. So limit n tends to infinity. Minus 1 by the square root of 1 plus 1 by n squared plus the square root of 4 minus 1 by n squared. Now you can plug in the values. Minus 1 by, I don't think it will be visible, so I'll just erase the top part. I guess you copied this. I hope you copied this actually. So okay, fine, I guess it's visible. Here, okay, fine. So now you can plug in the values. Minus 1 by the square root of 1 plus 1 by infinity plus, in infinity power anything is infinity, you can just, it's just uncountable. 4 minus 1 by infinity, okay? So 1 by infinity is 0. That's because infinity can be 9 into 10 power goes on, okay? So that's a very, 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 very big number, okay? So 1 by that much big number is a really, really, really small fraction number. So if you convert it into decimal, it tends to 0, okay? So this equals minus 1 by the square root of 1 plus 0. 1 by infinity is 0, right? Plus the square root of 4 minus 0, okay? So that's minus 1 by the square root of 1 plus the square root of 4 equals minus 1 by 1 plus 2 equals minus 1 by 3. So that's the answer for this complex question. So not that complex if you think differently after all, right? Okay, so going on, we'll look about some different difficult but interesting addictive things. So that's it for today, guys. Bye. See you tomorrow.